I want to tell you one thing that see VLSA means chip. VLSA means it's a chip. What will be there inside the chip? One circuit. One circuit. It will do some function. Okay. It,
Okay.
it will do. It will follow Boolean algebra. Complete Boolean algebra.
Okay.
So it will take
Okay.
zeros and ones. It will produce the output, required output. For example, there
Okay.
is an F full adder, uh, half adder,
Okay.
full adder, or half adder, or whatever may be the circuit. Okay, it will
Okay.
it will produce its required output. That is that.
Okay.
So, for example, what we will take is we will take one circuit known as, for example, which circuit we will take. Mm. Any ALU.
Arithmetic logical unit.
Yeah. If you take that circuit, then it will do 9 operations, right?
Yes.
That have input pins and output pin. Based on how many number of inputs you are giving, that based on the opcode and operand and uh, its its functionality. For example, it has to do first addition, multiplication, division, subtraction, and so on. All these things it will do. But how will you verify that functionality? That is very very important.
Okay.
Verifying that functionality,
Okay.
that we can give hardwired test bench. That is called test bench. Test bench means all
Okay.
stimuli we will give in a lab. What we will do, for example, if one uh, for example, any circuit, low pass filter, high pass filter is there, then we will give inputs, we will get the outputs, we will draw the response, and we will understand that it is working properly. Similarly, for digital
Yes.
circuits, we will give stimuli, we will call stimuli, that is nothing but inputs. We will get
Okay.
output,
Okay.
required outputs. We know the logical functionality. Add means, adder
Okay.
means it will sum, adds.
Okay.
So based on that, we will get the response. We will get the response, and
Oh,
we will verify. We will verify with
okay.
functional value with output value. If those two values are same, then data match, which means that circuit is functioning correctly. First, you need to learn the functional. There are so many verifications. Among them, what your job is, you need to find out logical functioning.
Okay.
Logically, that circuit before it going to the fab means fabrication, chip level. We will do this logical functioning and ensures that the circuit is working properly for any input. It has to work for any input. To check, for example, you have a processor, newly came processor, 128 bit. Okay. Okay,
Okay.
you forget about that much big circuitry. First, you two input AND gate is there. To check its functionality, how many set of inputs we need to give to find out its functionality.
And gate, right?
Yeah, AND gate.
Two inputs will have to give.
How many combinations we need to give to check whether that's
Four combination.
four combination. 2 power 2 is 4, right?
Right.
That hardwiredly manually we also can give four combinations. But
Yes.
there is a processor, advanced processor for Apple 16 watch, that is 128-bit processor, for example.
Okay.
How many inputs you need to give it? How many combinations you need to
One
give?
processor is how many input processor has how many input bits?
128-bit.
128. This is thousands of inputs we'll have to give.
2 power 128 means it's
Super.
billions and billions of combinations that we cannot
Input.
give it lifetime. So for that,
Yes.
there is an alternative technique. Okay, the
Okay.
technique is we will give random numbers, randomly some numbers we will give, and we will check its
Okay.
functionality. That is for
Acha, okay,
that is also it will take so much time. For one regression test, it will
okay,
be taking so much time to check. But still, compared to previous raw thing, this this these numbers are called pseudo random noise generators. Pseudo random
okay,
noise generators will generate a pseudo random noise value, and it will uh, uh, it will give uh, it will give output. We will compare that output with the expected output. If it is matching, then circuit is working. So it will check only 70 to 80% of the functionality. That's it, right?
yes.
That is called bucket. Okay. So that is called bucket one. Bucket one means that is premium mobiles. So the
It will
why?
check 70 to 80% of the combinations, right? Functionality.
Yeah, not entire functionality. That is also very good. That is premium quality. That will be comes market to very first. Mobiles will come first. After that, same mobiles, uh, 60 to 70% it is uh, covering verification is covering 60 to 70%. Then it is called second level, second bucket. That will come the
Okay,
same mobile also after some time. They will really, they don't throw the mobile. They will manufacture billions of mobile, but first mobile they will send it, they will sell it, for example 1 lakh Apple mobiles. After that same mobile they will sell at 80,000 or 70,000 after 6 months or
okay,
one
I
year.
understood.
After that,
Okay, sure.
after again 1 year they will sell it 50,000. So why means
Yes,
that is test that is coming, that have more bugs. Okay. Likewise,
okay.
that is called buckets.
B-
Okay.
Okay,
See,
more bugs are there, more the less the price of the mobile
yes,
phone
yes,
is.
yes. So for this test
Okay,
bench, okay, it have a standard test
okay,
bench. You need to learn two test benches only. System Verilog test bench, and
okay,
there is a Verilog test bench for this hardware language. Okay,
okay, very log test bench.
Verilog test bench.
Hmm.
In Verilog is a language, hardware description language. What it will do is, if you write, for example, uh, sum equal to A XOR B XOR C, three input AND gate, and carry equal to A and B plus B XOR C. If you simply write the code on the tool and you synthesize, the circuit will be generated on the chip, either ASIC chip or FPGA
Okay,
chip. Okay, that is too fast and
okay,
too good. That is called synthesis.
okay,
Those things and all you need not to go. That is design. You need to go for verification. So the circuit is already
okay,
built. That how you need to verify. So for that,
okay,
you need to learn some basics.
okay,
There is one website. Don't go anywhere, any other material other than this website. That website name is
okay.
verification guide. Verification guide system Verilog.
Verification time.
Okay, I'll give.
Okay,
I gave
the
all.
link you already gave that link.
Yeah, I thought you people might have went through it. I'm not sure. Okay, if you don't go, also not a
I've
problem.
also already went through the same. Went through the same. I
What you
already went
understood?
through the
What you
same.
understood from that?
I understood that there are like it's the HDL is all of hardware description language, and it's used for the verification. Verilog is a kind of HDL, and need to use it for the verification. Verification, maybe there are many modules in the verification in the test bench that are used,
Yeah.
and it's all and all about verifying a proper already designed circuit and using the coding in the same. It's all and all about coding.
Okay. You need not to go to this evolution history and all. First, you need to go to. Okay.
Okay.
Can you people see my screen?
Yeah. Yes.
See here. This is his history. Okay, 2012. Okay, IEEE 80,000 2012. This is the history. This came from very low level and it came to very high level. This is very advanced. Now we are using system very low. And UVM, that is universal. Okay, more than that it won't come.
Mm-hmm.
So your lifelong. Okay, system Verilog components.
Okay.
Okay, system Verilog language components are concept of Verilog HDL. test bench construction based on Vera, open Vera assertions, synopsis VCS direct C simulation interface to C and C++. So here,
We need to learn C, C++, and
no
HDL.
need, no
All
need,
the three.
no need.
Okay.
Only test bench coverage assertions you need to learn.
Okay. Test bench assertions and coverage. Okay.
System for verification. See, if you are verifying one system, that is called a circuit, that is called a chip. So for that logical chip, that is okay, not a physical, they won't
Okay.
fabricate without
Okay.
verification. So for that, that
Okay.
is called your design under test. That for that design under test, what you will give is, you will give stimuli, that is called input, and verify
Okay.
output. We have referenced output, what output we will get. For example, one AND gate is there, I'll explain with this so
We
that.
already have expected output and we will match the output with the expected output.
Very good, that's it. You are sharp,
Yes.
you are sharp, Neha.
Thank you.
About test bench.
And we'll give the inputs using P, R, and G, right?
PRNG, correct, pseudo randomized generator. See here,
Okay. Hello.
what's happening?
Voice is not audible. Let me check again. Give me 2 seconds.
Your voice is audible now.
Okay, my voice is audible. Your voice was not coming. Okay, you can start. You can start again. Hello.
Now it is audible.
Hi,
Ah,
yeah,
yes.
now it is audible.
Okay, okay, sorry if I'm it's my mic problem. And see, first class is transaction class. These are all classes. Class means what?
Okay.
It's OOPS, right? Object oriented programming. Class, object, abstract class, virtual, this, super. These are all under comes under OOPS concept. Object oriented programming. Objects. So
Okay.
first class is defines pin level activity generated by agent to drive to DUT through the driver, or the activity has to be observed by agent placeholder for the activity monitored by the monitor on DUT signals. మనకి DUTకి ఏవైతే Oh, Telugu. Sorry, I'm getting Telugu language. See, whatever
Okay,
the
okay.
signals,
Okay.
whatever the signals are there for DUT, okay,
Okay.
whatever the signals are there for the DUT, the same signals we will declare in transaction class. That's what it means. Okay.
Okay.
Next class is
Okay.
Next class is generator. What it will do is, it is also a class, generate the stimulus, create and randomize the transaction class. Here it will take instance of the transaction class as tr, that tr dot randomize, that so it will randomize,
Okay.
so it will give random value, any random value. Okay, for example,
Okay.
if in our test case for corner cases, if we want any specific number, for example, if we want 10 or 20, okay, or less, or 20 to 30 only, or 40 to 50 only, like this, there is any constraints, at that time we will use constraint c. Okay, in that
Okay.
constraint block we will give, so flower brackets we will give 20 to 30 with that variable.
Okay.
Okay, next,
Okay.
driver receives the stimulus, okay, transaction from a generator. Okay, how it will receive means, there is a IPC in between, interprocessor communication. That IPC, one
Okay.
mailbox will be there. Okay, generator will put that mail data in that mailbox and send it to driver. Driver will get the, that will use the method name as put. Okay, it will receive as
Okay.
get, driver receives as a get. Okay,
Okay.
and
So generator will send the signal to driver.
yeah, through mailbox.
Okay.
So driver will generate and drives the packet level data inside the transaction pin, and
Okay.
and that will go through the uh, interface, virtual interface, and that through via virtual interface will be with respect to, driver, those are outputs, output signals with respect to driver, with respect to interface input. So again it will be, there is a confusion with respect to, I'll show like, uh, where is the paint. This is driver. Okay,
Okay.
this
Okay.
is an interface.
Okay.
See, driver output signals, driver output signals, interface looks like an inputs. Again, driver interface output signals, there will be DUT or DUV, device under test or device under verification. Okay, DUT.
Okay.
This will see inputs as this. So it will get confusion. Which one is the outputs, or which one, with respect to this is with respect to driver it is inputs. With respect to this is output, this is inputs. Okay.
Okay. The reference point is different for the output and input for driver interface and DUT
Yeah,
both.
yeah.
All the
That's
three.
that's why for this input signals we will give as a logic. We don't give it as